Shai, are you familiar with Heisenberg's uncertainty principle?
I can't say that I am.
Well, it states that the more accurately we can measure the velocity of a particle, the less accurately we can measure its position in space.
What do you mean?
I'll show you.
Heisenberg's uncertainty principle is one of the most famous principles in quantum physics. The uncertainty principle exists because everything in the universe behaves like both a particle and a wave at the same time.
Wavelength is essential for quantum physics because an object's wavelength is related to its momentum, mass times velocity. A fast-moving object has lots of momentum, which corresponds to a very short wavelength. A heavy object has lots of momentum, even if it's not moving very fast, which again means a very short wavelength. This is why we don't notice the wave nature of everyday objects. If you toss a ball up in the air, its wavelength is a billionth of a trillionth of a trillionth of a meter, far too tiny to ever detect. Small things like atoms or electrons, though, can have wavelengths big enough to measure in physics experiments. So, if we have a pure wave, we can measure its wavelength, thus its momentum, but it has no position. We can know a particle's position very well, but it doesn't have a wavelength, so we don't know its momentum.
The Heisenberg uncertainty principle is normally written as delta x, delta p is greater than or equal to h over 4 pi. So what does this mean? So delta x is the uncertainty in the position and delta p is the uncertainty in momentum. Now, h is Planck's constant and that's a very small number.
To demonstrate Heisenberg's uncertainty principle, we have here a laser and a slit. The laser will shine through a narrow slit onto a screen. But as we narrowed the slit, we were decreasing delta x for those photons. So we were getting more and more precise about where the photons were passing through that slit. And in a certain point, you come to this limit so that if you narrow this any further, you are going to break this uncertainty relationship. And the more you decrease your uncertainty in position, the narrower you make that slit, the more the uncertainty in momentum has to go up. And so, if these photons are going to the left and the right, that is going to produce a much wider beam.
If the uncertainty in one parameter decreases, the uncertainty in the other must increase. If one becomes known with total certainty, the other becomes unknowable.
That's the Heisenberg's uncertainty principle, first stated by Werner Heisenberg back in 1927.